And I am a computer engineer, or I used to be a computer engineer, and now I teach maths. I guess everybody out here is to first a little bit of background about me. So I am from India. I did my engineering from Delhi University, and after that I moved to America to work as a developer for some companies. I have worked for EMC, now known as Dell. I have also worked for HP, Fujitsu, NTT Telecom, and a lot of big names here and there. I have worked in um, India, Malaysia, Japan, China, America, and Australia as a computer engineer. And after that, essentially, I left computer engineering and now I am teaching maths. I have three children. My oldest daughter is in year 7 going to year 8. My son is in year 5 going to year 6. And the youngest one is will turn 3 next year. And I think people have a lot of questions here about Olympic maths. The first thing I will like to say about Olympic maths is it's not about solving extremely difficult questions. It's more about finding an easier or a faster way to solve a question and then try to remember it so that you can use the same technique on something else. And I like to demonstrate a couple of things out here. So I will divide the children into two groups out here, years 3 and 4 and years 5 and 6. So I'll share the whiteboard and then we'll go from there. So the first question is for children from years 3 to 4. It's a very easy question. Vicky, uh, I think Vicky knows how to answer. I'll unmute Vicky.
The answer is 8,888.8.
Are you sure there is a 0.8 in the answer?
Well, you can remove the 0.8 because 10 can't fit into 8, but just do the 0.8.
Okay, very good, Vicky. The answer is correct and incorrect. If you just answer 8,888, the answer is correct. But with the 0.8, the answer becomes incorrect. Mainly because like we are only interested in how many tens. Now there's another way of doing it. Since we are asking for tens only, what I will do is I'll just remove the first 8, which is the units digit. So my answer is 8,888, and I don't need to divide at all. So this is something that a lot of children need to understand, that we don't really need to do division. You can do, there are other techniques to help you get to the answer a lot faster. I will try to demonstrate this with another question, and this is for children from year 5 to 6. It does not mean the children from year 3 to 4 cannot try it. So let's see. This question is from this year's Maths Olympiad for years 5 and 6, Australian Maths Olympiad for years 5 and 6. This question is a little bit on the harder side for years 3 and 4, but for years 5 and 6, it should be okay. It might take a little bit of time to solve the question. And what I would like to stress out here is that most of us like to do addition from right to left. We try to add the units digits first, followed by the tens, then hundreds, and then thousands. What I will suggest to all the children out here is go left to right. A little bit different from what you are used to, but go. Try to add all the F's first, followed by the O's, and then the T's. It will help you achieve the answer a lot faster than going from left to right. Any ideas, anybody? Okay, let's see. Okay, so now if we look at it a little bit, what we will realize is that the three F's together lead to a Y, and there is no carryover, which means that Y has to be less than 10. Now it also says that I need the biggest value of yard. So for the biggest, we have one person. Yes, Vicky? Hello? Vicky, yes?
Is it 9,999?
9,999. Well, I will say one of the nines is correct. But if you look at it, you have got YARD. They are different digits. So, and what you have here is YYYY. So can you please try again? And as Vicky said, so maximum value of Y we can get is 9. So I will replace Y with a 9, which means the F's have to be 3. Now, the next we come to O's. Now, since my Y is 9, which means I cannot have any carryover from the O's to the F's. So the carryover is not permitted. So what's the other value of O I can have? I can have it 3 again, but 3 is already taken. The only other numbers that I can have is 1 or 2. But again, we refer to the biggest value of yard, which means the only number I can use to make it as big as possible is 2. So I'll use 2. I will not write the values of ARD as yet because I'm still working it out. I'm not sure whether I want any carryovers or not. Now let's look at the value for T. Now I want T to be as big as possible because there is no restriction on the carryover here. The biggest value for T I can use is 8, as 9 is already taken. This gives me 4 here, 24, with a carryover of 2. And that makes it 8. Now, most people will think that is the correct answer, but again, it is incorrect. Mainly because 8 has already been used and we cannot have an 8 again. So what I will have to use is a little bit lower, a 7. So D becomes 1, R becomes 8, and A becomes 6. The answer here is 9687. Oh, I'm sorry, I think I erased the question by mistake. I'll put the question back. Vicky, did you get it? Vicky, did you get it? Okay. I will assume it's a yes. So what is to be remembered out here is that we cannot go left to right as we are used to in an addition. For this kind of cryptorhythm, we have to go left to right. And that is something that a lot of children do not know about. And that is why they take a huge amount of time to solve it. In a typical maths Olympiad, you will get around 5 minutes to solve this. And if you know you have to go left to right, you can solve it in within 2 to 3 minutes. But if you don't know it, it will take you a good 10 to 12 minutes to solve. And then you have run out of time and you don't have time for other questions. Okay, my next question will be again for years 3 and 4 this time. This is one of my favorite questions. So this question is again not made by me. This question is from a The reason I know about this question is that because my daughter was in her school's team and I have just put a snapshot of the question. The actual question was using the 4 fours to make the numbers 1 to 100. It's a beautiful question. So Claire, yeah, Claire, can you do it?
Brandon, you say it.
Can't you say it?
你说 how to make it 3.
4 times 4 minus 4 divide 4. Yeah.
Perfect, correct. Absolutely
Hey.
correct. Claire, can you do it another way?
You do it another way?
Right. The beautiful part about this question is that there are multiple ways to do the same thing. And if you try to make the numbers 1 to 100 using the 4 fours, you actually learn a lot of functions in maths. You learn about squares, you learn about square roots, you learn about factorials. Vicky, any idea? Claire, can you do it? Yes, Claire?
Brenda,
4 plus 4 plus 4
10.
divide into 4.
Wonderful work. Correct again.
8.
So as we saw that it's a beautiful question and you have two ways to solve it right now. But if you use root, there's another way to solve it. I will not use root out here because I specifically said it is for years 3 and 4. And they have not been introduced to the concept of square roots.
Brenda 厉害，我都没想到。
I'm sorry, somebody was saying something? Was somebody asking a question, please? So now I'm going to make this question a little bit harder and exactly the same question, but now this is for years 5 and 6. Instead of a 3, we'll make a 13. So any ideas? The interesting part about this Da Vinci decathlon is that every year group gets the same question. They do not differentiate between different year groups. Claire or Vicky, any ideas? Okay, this one needs a little bit knowledge about some other concepts in maths. For example, factorial and root. So out here, I will use 4 factorial, which essentially means or 24. Once I have a 24, I can divide it by root 4, which gives me 24 divided by 2 or 12. And after that it is a difficult way to get a simple answer. So it's essentially 4 factorial divided by root 4 plus 4 divided by 4. And now when the children, what I will suggest is that everybody ask their children to make it. And you will realize that how much will the children learn just by a very, very simple question. If you try to make the numbers from 1 to 20 using this just 4 fours, you will learn a lot of things in maths. You learn the concept of roots, you learn the concept of squares, you learn the concept of factorials. And this is something that is not easy to teach in a single class, but just a simple question can teach you everything, how to use it. And I am not saying this is the only way to make it. There are other ways, and somebody can easily make a much better solution than what I have done here. I'll clear this out and let's go to the next question, which is for, this is essentially for everybody. Anybody from years 3 to 6 should be able to do this. If I remember correctly, this is from one of the Singapore Maths Olympiads. I have tried to make the question a little bit easier than what they had. They essentially had a 3-digit number. I have made it a 2-digit number. And they had, and you could use digits from 0 to 6 in that question. I am just giving 5 digits. Clear? Yes, clear?
You do it. You thought of it.
I'm sorry,
Come on.
clear? Please repeat.
Yeah. 从 tens 开始说。
11, 13, 21, 23, 33, 31, 41, 43.
Yeah. Now, clear is correct. But the fact is that Claire took a lot of time to do these numbers. And what I am going to do is that I am going to increase the complexity by saying, let's make 3-digit odd numbers. Suddenly the complexity increases by a whole factor and exponentially increases. And it's very, very difficult to find all the numbers, especially in a limited time frame. Singapore Maths Olympiad is a little bit different from the Australian one. They have got a lot more questions which have to be solved in an hour. So you will get around a minute to solve this question. And this is the slightly simpler form of the actual question. So this is where we learn about combinations. Out here, the question is asking 2 digits, which means we have 2 spaces. Now it says it has to be an odd number. The things to choose from are 0, 1, 2, 3, and 4. Out of an odd number means it can only end with 1 or 3. So we have got 2 choices for the second number. Now for the first number, we have the choices 1, 2, 3, and 4, which is 4 choices. We cannot use 0 as our choice because no 2-digit number can start with a 0. What we do next is we multiply these 2 numbers and our answer is 8. Now if we use this technique, we don't have to really think a lot about every single combination. Let's change it to a 3-digit number now. It's extremely easy now. Since it's a 3-digit, we have got 3 spaces. The numbers remain the same: 0, 1, 2, 3, 4. Which numbers can we put in the third space? Only 1 and 3. So we put there 2 choices. Which numbers can we put in the second space? Anything. We don't really care. So 1, 2, 3, 4, 5 choices. And now for the first space, we cannot put a 0. Oh, sorry, somebody raised a hand. Sorry about that. Yeah, clear?
Sorry, I just didn't lower my hand.
Oh,
Sorry.
that's okay. Vicky?
Is the answer 24?
Okay, so let's see. So how many numbers can you put in the first space?
2.
Are you sure about that? Because I think I can
the
put
first
one.
space what do you mean, the last space? The one with the
First space. It's a 3-digit number.
3?
Yeah, so in the 100 space, which numbers can be put?
1, 2, 3, and 4.
So we have 4 choices, right?
Yes.
Now we
No,
multiply.
only 1, 2, 3, and 4. That's only 3. 0 does not count.
Yeah, 1, 2, 3, 4. That is 4 choices, right?
Oh, yeah.
Okay, that's fine. That's
Sorry,
just
I got a calculation wrong for that.
that's okay. That does not matter. Your thought process is correct. That is what matters. We all make mistakes with calculations.
It's
So
4
then what we do
times
is,
5.
yes. So how much is that?
20 times 2. So the real answer is 40.
Now, the fact is, if we don't do it like this and we start writing all the combinations, I can assure you that you will miss a couple. Like the way Claire did it before, if we had started writing everything, so we would be still writing 1, 1, 1, 1, 1, 3, 1, 2, 1, 1, 2, 3, 1, 3, 1, 1, 3, 3. And after some time, we just start getting bored and we start making mistakes. So we need to learn how to find combinations quickly. And this is an easy method of doing it. And the same question, let's say I change it to even numbers. It's still done exactly the same way. We have 3 digits, which means we have 3 spaces. How many numbers can go in the unit space? 0, 2, and 4, which means we have 3. How many numbers can go in the 10 space? Anyone, we don't really care. So we have 5. How many numbers can go in the hundreds? 1, 2, 3, and 4. 4. Multiply them together and our answer is 60. We could do it in less than a minute. We start writing all the combinations, pretty much the whole exam is gone. So what I am trying to show out here is that Olympic maths is not really about solving a really difficult question. Olympic level maths is essentially learning techniques to solve questions faster, to do things easier. And hopefully this way we will be able to do a little bit more difficult question, a little bit more we develop a little bit more logic, we develop a few more techniques. Okay, this question that I'm going to ask is specifically for year 3 and 4. And if you are in year 5 and 6, I will, please do not answer it because it's way too easy for you guys. Ajay is the name of my son. So in most questions, I use the name of my son or my daughter. Okay, Vicky. Vicky, which year are you in?
I'm in year 4, going to year 5.
Okay.
Okay, the answer is 50 grams.
Very good. The answer is correct. So how do we do for most year 3 and 4s? This is a little bit difficult question because they have not been introduced to algebra. And the fact is we don't need to know any algebra to do this. Cheryl, yes?
Sorry, I'm in year 5.
Hi. So what's the answer here, Cheryl?
50.
Good. The answer is correct, 50 grams. Okay. So how do we do this kind of a question? So what we do is we write what is known to us. So here, we bought a drink and it weighs 650 grams. Now the drink comes in a bottle. So can I write bottle plus drink equals to 650? And then I drank half of it, which means the bottle still remains, but the drink becomes half. Now, most of the adults will be thinking this is algebra. And it is. But what we are trying to show it to the children is, without using algebra, how to do it without actually mentioning the word algebra. So now what I ask the children is, what is the difference between these two statements that I have written? Find the difference. The difference is on the left-hand side, and I asked them the difference on right-hand side and the left-hand side. The right-hand side is pretty easy. Everybody can do it. It is 300. And on the left-hand side, almost all the children can do it, and they will say half the drink. Which means half a, yes, Vicky?
So you literally just minus 300 again, right?
Yes, you're absolutely correct. So we know half the drink is 300, which means the drink is 600. Now what I do is, in the first one, I replace the drink with 600. So we have got bottle plus 600 equals to 650. And I have never seen a child who has not been able to answer this, that the bottle equals 50. But if I started to explain it using X and Y, I don't think anybody from years 3 and 4 can do it. And this question is essentially from an ICAS year 3 paper. I don't remember the year. The question was not exactly with a drink and a bottle, it was with a plate and a piece of cake. So just an easier way of doing something that is a little bit more difficult at their year level. Not exactly a difficult question, but just for that particular age group. Now what I'm going to do is I'm going to ask the same question for years 5 and 6 and show it how it can again be done without using algebra. So this question is now for years 5 and 6. And essentially this is like, let us say that this kind of question is very, very popular in the selective and the scholarship exams. If you look at the latest selective exam sample paper that is on the website, they have two questions that are extremely similar to this. Now, again, most adults here will say that it's very, very simple using simultaneous equations using algebra. But the whole idea is to do it without using algebra. Yes, Vicky?
The answer's 30.
I'm sorry, how many?
30.
30.
Yep.
Okay, so we'll just write it here. And now we are going to solve it to see whether you are correct or incorrect. Is that okay?
Yeah, sure.
Thank you. So this answer was given by Vicky. So now how to solve it without using any algebra? So what I do is I make a table. I put cakes here. I put bread here. And I put $$ here. I don't know how many cakes I sold or how many. We have a raised hand from Catherine. Yes, Catherine? Catherine?
Say how many cakes?
20.
So Catherine, you got 20 cakes?
Yes.
Okay, perfect. So let's see whether you are correct or not. And we have another raised hand from Cheryl. Hi, Cheryl.
I think it's 80.
I'm sorry? Yes, Cheryl, what answer did you get?
80.
80. Okay. I have a feeling Cheryl is correct, but we will check. So what we do is we just put any number of cakes and any number of breads as long as they add up to 100. Now we sold 50 cakes, so that is 50 times 5. 250. And 50 breads, that is another 150. So that gives me $400. I have to make $460. So I will increase the number of cakes out here because cakes are more expensive than breads. How much should I increase it? Again, I have absolutely no idea. So I'll just increase it by a little bit. I make it 60 and 40. This gives me 60 times 5, which is 300. 40 times 3, which is 120. I went to 420. Now this is where the intelligence is. The difference between these two numbers is 20. I increased the number of cakes by 10. The amount of money increased by 20. The amount of money I needed to increase was by 60 from the first one. So I will have to increase the cakes by 30, which is 80 and 20. 80 times 5 is 400 and 20 times 3 is 60, which gives me 460. Or I sold 80 cakes. Well done, Sharon. Vicky and Catherine. Catherine, I think you switched the cakes and the breads around. You were on the right path, but you just switched them around. And Vicky, I think you made a calculation mistake somewhere. So just trying to show that things can be done without using algebra, and it's not that slow either. If we are doing it at a normal pace, we should be able to do this question within a minute. And that is what they expect in a selective or a scholarship exam. A minute for this kind of a question. Catherine, do you have to say something? Catherine?
Assume.
Okay, we'll move on. Okay, this question is for years 5 and 6 is only. I'm sorry for the years 3 and 4. It's a little bit on the difficult side for years 3 and 4. So I will not ask them to attempt it. This question is from a selective exam. I'm sorry, I forgot which one, which year, but this is from one of the selective exams. Again, this is I love this question mainly because of the number of things it teaches. Catherine, can you answer this first?
No.
I think I lost Catherine. Okay, clear?
7:30.
Beautiful answer. Very, very good. Absolutely correct. Thank you, Claire.
Thank you.
Okay, so Claire just answered it. The correct answer is 7:30 p.m. Now, how did she get to this answer? I'll just draw a simple clock. And I'm sorry about. So the clock more or less looks like a circle. And if I draw the minute hand on this, it's something like this, and it travels in a circle, which means when the minute hand completes a whole circle, it has moved 360 degrees. And when the minute hand has moved a whole circle, that means we have completed 60 minutes or 1 hour. Now what we had to do was find 540 degrees. So we do 540 minus 360, which is another 180 degrees. 180 is exactly half of 360, which means we have traveled another 30 minutes. So to 6 p.m. we add 1 hour, 30 minutes or 7:30 p.m. The actual exam question was a little bit different from what I have asked. I have made it a little bit easier. The actual question was essentially, what they did was 450 degrees, which is again the same thing. It's not that difficult. All we need to change here is 90 degrees, or 90 degrees makes it 15 minutes. So the time will be 7:15 p.m. Okay. I will open the floor for questions now. I have received 3 questions from 3 parents. I'll put the questions out here so that everybody can see them, and I'll try to answer them one by one. So the first question is about how to train younger kids for Olympic math thinking. My answer to that is don't train them. Let them be. What you should rather do is arouse their curiosity and don't try to mold them into any specific path. For example, like when you guys are going for a walk, or you guys are going on in a car or anything of that sort, just ask them, like, why do you think the trees have leaves? If it's the autumn season, ask them, why do you think the trees are shedding leaves? Why are the leaves falling? During spring, the flowers come out. The children love to see flowers and smell them. Ask them, why do the flowers have different colors? Like the other question could be that, why do you think most flowers have 3, 4, 5, or 8 petals? And then we can introduce the concept of Fibonacci series. Why is Fibonacci? And once you have introduced the concept of Fibonacci series, we can show them why it is called the God series. But in general, my idea is not to train kids as young as in year 1 or year 2. Like I would let them be and just arouse their curiosity by asking different kinds of questions. Like if we are traveling in a car, I ask them that when the car in front of us stops, and every car has got brake lights. So why are the brake lights red? Why are the traffic lights red, yellow, and green? Because we are not trying to teach them maths. What we are trying to teach them is that everything is based on a certain reason. And if you like reasoning, if you like logic, you will do very, very well in maths as well. The second one is from Coco. This is how to increase kids' interest in Olympic math. The answer is extremely difficult. Maths in general is not that interesting to a lot of kids out here. Mainly because the schools here don't give a lot of importance to maths, unlike my country, India, or China, South Korea, Japan, and Singapore, where maths is given a lot of importance. Out here, maths is, yeah, so what? One of the main reasons I have seen the kids are not interested in maths is because of the peer group they are in. If their friends do not like maths and the children do like maths, they will be quite embarrassed to say they like maths. So the kind of the friendships they form make a very important part in whether they will do maths or whether they will do more harder problems in maths or not. And the other thing again is that reasoning and logic. Most children do not like maths, but they love science. So let's do science with them. Eventually, what they will see is that science and maths converge. The base of all science is maths. A very simple thing, like when we take a photo using a camera. If you have realized that in the dark, it takes a little bit longer to take a photo than when it is light. Why? Why do you need a longer exposure time? The same question that I was talking about with traffic lights. Why is the red traffic light to stop is always red? Is there a specific reason behind it? If they start thinking about it, we can ask them, why do you think during the evening we see the red color of the sunlight? Why don't we see the blue color or the white color? Essentially, what we are trying to show is that red has the longest wavelength. It can be seen from the furthest distance away. And once they start understanding this, they will ask you what is wavelength. And now we start coming into a lot of math. The third one is, are there any official maths Olympiad tests for Aussie kids? There are two actually. Sorry, when I say two, I mean to say there are two organizations that conduct it. The first one is done by APSMO. I'll write it down. They do it for years 5 and 6 and years 7 and 8. The second one is AMC, which is the actual maths Olympiad for Australia. This one is a lot harder. APSMO, most schools will participate in APSMO. Very few schools participate in AMC. And you actually have to specifically ask, I mean, you can go to the AMC website and register out there. But if you want to do it through the, sorry, not AMC, AMT, sorry, Australian Maths Trust. You have to register out there. If you are going to do it through the school, very, very few schools do it. I'm not exactly sure why so few schools are interested in it, but most schools try to steer clear of AMT because the results usually are quite poor and they don't like to put it up. But that is the actual Maths Olympiad for Australia. And this is where from the Australian Maths Olympiad team is chosen for the International Maths Olympiads. I'll turn it back to Vinci.
Okay, thank you, Mr. Bhavesh. Thank you for your webinar.